Yes, students, listen. So yesterday we completed almost. Listen. Yeah, yesterday we completed substitution and elimination reaction, types of substitution reaction, types of addition reaction, right? And mechanism. So today we will discuss some more example. It may be useful for your exam. Okay, CT2 exam. For CT2 exam, up to addition reaction is there. There is no oxidation, there is no students, listen. There is no oxidation addition, there is no oxidation reduction reaction, there is no pharmaceutical preparation process. Except that everything is there. Okay. So right. Now we go for the electrophilic aromatic substitution reaction. This all is a well-known example. Already you know about it. Electrophilic aromatic substitution reaction. There, in the aromatic ring itself, we do the substitution. Okay, aromatic ring itself, we do the substitution. For example, you take a benzene. Okay, you take a benzene. You try to write it in your notebook. Then only you get the practice. Okay. You try to write it, all the reaction in your notebook. Then only you get the practice. When you sit in the exam time, it is very useful for you. Okay, right. So you take a benzene. First, we add the nitrating mixture. You know the nitrating mixture, right? Sulfuric acid mixed with the HNO3. Okay, sulfuric acid mixed with the HNO3. That is the nitrating mixture. When you add the HNO3 and H2SO4. H2SO4 here. Maybe I can draw like this. Okay. NO2. This is a nitration reaction. Nitration. And similarly, if you add the Br2, Fe, Br3, ferric bromide. The ferric bromide only initiates the bromination reaction in the benzene. So you get the bromobenzene. Right? What is this reaction? Bromination. Addition means addition. NO2 addition, nitration. Br addition, bromination. And next, similarly, you can go for the another reaction, Cl2, that is FeCl3. You know the same reaction only, but instead of bromide, Cl addition. It is a chlorination, right? Chlorination. And next, you add the HOCl. Plus H plus and Ag plus, that is silver chloride, anything you can take it, and in presence of acidic medium, what happened? The same chlorination reaction. Okay, chlorination. Then sulfonation.
Sir,
that
this
is
is called electrophilic aromatic substitution.
Substitution reaction. This is a electrophilic aromatic substitution reaction. H2SO4, what happened? That is sulfonation reaction. SO3H. Okay, SO3H. The same you can do for the acylation reaction. Okay, alkylation, acylation, CH3, CH2, Cl. So what happened here? The Cl and H from the benzene, it remove, you get the ethyl benzene. CH2, CH3. Okay, CH3. And similarly, you can add so many reagent is there. CH3, CH, double bond CH2. So what happened in presence of H3PO4? Right? That is 1-methyl-ethyl benzene. The first position methyl group, so 1-methyl-ethyl benzene. Okay, 1-methyl-ethyl benzene. Then you do the acylation reaction, that is CH3, C double bond O, Cl, that is also in presence of aluminum chloride AlCl3, you get the acylated byproduct, acylated product, C double bond O, CH3.
Sir, what is acylated?
This is the acyl group, acylation. CH3, C double bond O is a acyl group. Acyl addition, acylation. Chlorine addition, chlorination. Okay, acylation. And similarly, we can do for deuteration also. There you can add D2SO4. That is, instead of sulfidation, you do the deuteration. There H2SO4 is a reagent. Here D2SO4 is a reagent. Okay, that's it. So here you get the, instead of one proton, it replaces the D, deuterium. The HDSO4 is your byproduct. Okay, HDSO4 is a byproduct. Maybe I can write it here. This is a nitration. Nitration. Bromination. Okay, bromination. Chlorination. Right? Chlorination. This is a sulfonation. This is alkylation. Yeah, this is also. Okay. This is also alkylation. Then this is acylation. This is deuteration. Okay, deuteration. This is the electrophilic reaction. Electrophilic substitution reaction. Okay, electrophilic substitution reaction. Otherwise, you write it one by one. No? H3PO4. Phosphoric acid. May I move the slides?
No sir, wait.
D2SO4, deuterium. Instead of sulfuric acid, deuterous acid we can take it. D2SO4. Instead of one proton, we add one D. So at finally, your product is HDSO4.
Sir, wait.
Okay?
Sir, can you for 2 minutes? 2 minutes. Sir, both of these are alkylation. Both of these are alkylation. This
Yes, both are alkali. Which one? Acylation. Acyl group addition.
And last one is
Last one, deuteration. DEUTERATION. Okay?
yes. Yes.
Yeah, next we go for the nucleophilic aromatic substitution reaction. Nucleophilic aromatic substitution reaction. So there we can do the nucleophilic, okay, nucleophilic aromatic substitution reaction. Take for chloronitrobenzene, okay, NO2 and Cl. If you add NH3, NH3 means you know that is some excess amount. NH3 is a gas. You can pass the NH3 gas into the chloronitrobenzene. So what happened here? The substitution is happened in the chlorine side. Okay, chlorine side. So therefore here NH2, here NO2. Already NO2 is there. There is no problem. So NH2 substitute instead of the chloride. Okay, instead of the chloride. So already NH3 is a excess amount. Therefore NH4 Cl is your byproduct. Because NH3 we have to pass continuously. So therefore,
Can you repeat?
yeah, this is a chloronitrobenzene. So we can add the NH3 gas, that is a NH3. You can pass continuously, that is a excess amount. Okay, excess amount we pass into the chloronitrobenzene. There, the Cl is a leaving group. Therefore, NH3 is approached towards the Cl side. So Cl is removed and it add to the NH4Cl. That is your byproduct. Okay, that is your byproduct. Therefore, you get the NH2 substituted instead of chlorine substitution. That is your byproduct. Sorry, that is your main product. Ammonium chloride is your byproduct. Okay, ammonium chloride is your byproduct. Similarly, if you do for the same CH3ONA, CH3ONA means what is your product? What is your product? Cl and ONA removed, right? So therefore you get the product is NO2 OCH3. Okay, NO2 OCH3, just NaCl removed. Okay. These are all reaction only. So first, where the leaving group is there, okay, you know that SN1 are in substitution, elimination, addition reaction. First, where the leaving group is there, we have to find it. So this is a leaving group for this compound. Therefore, here only the substitution is happened for your incoming compound. Therefore, here the substitution is happened, which means the OH proton, it remove the chloride, you get the product. Okay, you get the product. Then I will give the practice question for you. You can try to say where the substitution is happened. Or else substitution is happened or not. Or else substitution elimination is happened or not for that following compound. Okay, like may I write it here, this side? Maybe this is a continuation only. So next, this is for your different example. This is a meta-nitro compound. Okay, meta-nitro compound. If you add that here peptide group. Not focus that peptide group and all. Okay, peptide group and all. Just what happened here and what is your product. So here leaving group is fluoride. Therefore, that fluoride only it react with NH2. So what is your product? Here already NO2 is there. NO2 is there. In that fluoride, the H remove NH peptide. Okay, peptide double bond O R group. This is a nucleophilic aromatic substitution reaction. Nucleophilic aromatic substitution reaction. Maybe. Br double bond O. If you add SH, okay, SH, what happens here? Okay. Instead of ethanol we know the OH group is there. Instead of that, SH, ETSH. You know ETSH means CH3, CH2SH. Okay, maybe I can write it CH3, CH2SH. So here this bromide and hydrogen it removes. Okay, then S group it's just substitute. Okay, CH3, CH2SH. Right? Distorted. Type 1 or type 2. Distorted. Hexagonal. Yeah, student, any doubt? Any doubt? Anything doubt? Okay. Now I can move for some practice question. You try to find it that compound. It will go for the substitution reaction or else elimination reaction, like that. You tell me. Okay. You try to do it quickly. Okay, you try to find it. I'm not. Nemo. What happened? follows the, 1 minute, the primary carbon follows the SN2 mechanism. Tertiary carbon follows SN1 mechanism. Okay, so try to find it here where the substitution is happened. Where the leaving group is there, that carbon definitely go for the substitution. So look at here, this first one, where the substitution is happened.
Huh?
The first one, where the substitution is happened.
Sir, BR doing
Yeah, where the Br is there, this carbon substitution is happened. Therefore, this is possible. Substitution or elimination reaction is possible. And here,
BR.
yeah, this carbon is possible for the substitution and elimination reaction. Okay, elimination reaction. This is a tertiary carbon, hence it follow the SN1 mechanism. SN1 mechanism, right? And there, the next one. Here, the pi bond is there. Pi bond is there. So this is a sp2 hybridized carbon. sp2 hybridized carbon. This is right. This is the right, but this one no. sp2 hybridized carbon, based on the condition only, go for the SN1 or SN2, E1 or E2 reaction. Okay. Therefore, this carbon no. And here, next.
Sir, what is OPS?
OTS, that is a tosyl group. Tosyl group means that is a best leaving group. OTS.
Best.
Yeah, Cl, Br, OCH3, OTS, these are all leaving group. Leaving group means it's ready to leave from the carbon to form a carbocation. Which one is ready to leave from the carbon? That is a leaving group. That is a general name. So these are all leaving group only. Br, NO2, OCH3, OTS. These are all leaving group. Okay, right. So this carbon, yes, this is listen. So this is a leaving group. Therefore, it's ready to leave from the carbon. Therefore, it form a carbocation. Therefore, this is possible. Substitution or elimination reaction is possible. Okay, and here, yes, this is a tertiary carbon and leaving group is there. Here, substitution or elimination is possible. Okay, and here the pi bond is there, the chlorine is there. Okay, that is a sp2 hybridized carbon. Wherever the sp2 hybridized carbon is there the substitution and elimination is resting. Okay, we have to add some catalyst. Here also sp2 hybridized carbon. Here also sp hybridized carbon. Okay, sp hybridized carbon. Right? Maybe sometimes they ask in the MCQ question, in the following compound, which one is possible for the substitution and elimination reaction? Means keep it in your mind, wherever the sp2 hybridized carbon, there the substitution elimination is not possible. We have to add some catalyst. Okay, like FeBr3, FeCl3. That step only initiate the substitution reaction.
So there has to be sp3 carbon.
sp3 hybridized carbon means that is for SN2 mechanism. sp hybridized carbon, that is tertiary carbon. You know that. See, all substitute is there, that the SN1 mechanism is possible. So formation of carbocation is the first step, then nucleophile approach to the second step. Do you remember? Yesterday we discussed where the substitution and SN1, SN2 mechanism is possible. These are all practice question only. Tomorrow we move the next topic, oxidation reduction reaction. Like here possible. Here possible.
What are the conditions to be possible to elimination substitution?
Yes. Okay. sp3 hybridized carbon, it follow the SN2 mechanism. sp3 hybridized carbon, it follow the SN2 mechanism. Or else primary carbon. Primary carbon follow the SN2 mechanism. And tertiary carbon follow the SN1 mechanism. Tertiary carbon follow SN1 mechanism. Okay, SN1 mechanism. That itself is more. Primary carbon or tertiary carbon. Okay.
Primary or
Tertiary. Tertiary carbon follow SN1 mechanism.
tertiary?
Tertiary carbon. Tertiary carbon follow SN1 mechanism.
Also sp2? Also
sp2 hybridized carbon, no. sp2 hybridized carbon only I mark it, it won't follow. Wherever the pi bond is there, is attached near to the leaving group. There, no.
So sp2 and sp will not follow.
This is for your practice question only. Today I given whatever the question, that is for your practice only. Okay, anyhow we completed yesterday itself for our class, your CT2 portion. Okay, today I am discussing for your how you are answering the questions here. This is a MCQ question, maybe they ask from the question MCQ whatever I discussed today. Okay, right. Time is there, we move the reduction and oxidation.
Sir, for CT, which day is CT3?
CT3, CT2.
Which day is CT3?
You know that is your separate.
No CT3. What is surprise test?
Separate test your CT3. Okay. Marks. 10 MCQ, 2 10 marks, either are choice. 10 MCQ, 2 10 mark question, either are choice. Okay, ma? Total 4 10 marks is there, you have to write 10 2 and 10 MCQ. Same one period exam, 30 marks, it converted into 15 marks. Okay?